OSHA recommends the color magenta for marking off the working space in front of an energized electrical panel. This color coding system helps to quickly identify potentially hazardous areas and prevent accidental contact with live electrical components. The use of magenta tape serves as a visual warning to employees and visitors, indicating the need for caution and adherence to safety protocols. Maintaining a safe working environment around electrical equipment is crucial for preventing injuries and ensuring compliance with OSHA regulations. Proper marking of energized panel workspaces contributes significantly to overall workplace safety. Electrical safety standards are put in place for the safety of personnel and for organizations to meet certain requirements. Organizations must comply with safety standards and regulations to protect their workers. This often includes providing training, implementing safety procedures, and using appropriate personal protective equipment. An energized electrical panel presents several hazards. Firstly, electric shock. Contact with live electrical conductors can result in electric shock, which can range from a mild tingle to cardiac arrest, depending on the voltage and current involved. Secondly, arc flash. An arc flash is a dangerous electrical explosion that can occur when there is a short circuit or insulation failure in electrical equipment. Arc flashes produce intense heat, pressure waves, and molten metal, which can cause severe burns, blindness, and other injuries. Thirdly, electrocution. Electrocution is a fatal electric shock that occurs when a person comes into contact with a live electrical conductor on the ground. Electrocution can cause immediate death due to cardiac arrest or respiratory failure. Fourthly, burns. Electrical burns can occur when a person comes into contact with a live electrical conductor or an arc flash. Electrical burns can be very deep and severe, often requiring extensive medical treatment. Fifthly, fire. Electrical faults and short circuits can cause fires, which can spread rapidly and cause significant damage to property and equipment. Sixthly, explosions. Electrical explosions can occur when flammable gases or vapors are ignited by an electrical spark or arc. Explosions can cause significant damage to property and equipment, as well as serious injuries. To mitigate these hazards, several safety precautions are necessary. One must always energize the panel if possible. Before working on or near an energized electrical panel, always energize the panel by turning off the circuit breaker or disconnecting the power supply. Lockout and tagout procedures should be implemented to prevent the panel from being accidentally re-energized while work is in progress. Secondly, using personal protective equipment or PPE. When working on or near an energized electrical panel, wear appropriate personal protective equipment, including safety glasses, gloves, and insulated clothing. PPE can help to protect you from electric shock, arc flash, and other electrical hazards. Thirdly, maintaining a safe distance. Maintain a safe distance from energized electrical equipment and avoid touching any exposed conductors. Use insulated tools and equipment to prevent accidental contact with live parts. Fourthly, providing proper training. Ensure that all workers who work on or near energized electrical panels receive proper training on electrical safety procedures. Training should cover topics such as hazard identification, risk assessment, and the use of PPE. Fifthly, performing regular inspections. Regularly inspect electrical panels and equipment for signs of damage or wear. Replace any damaged or worn components immediately. Sixthly, implementing arc flash protection. Implement arc flash protection measures, such as installing arc flash relays and using arc-resistant equipment. Arc flash protection can help to reduce the severity of arc flash incidents. Seventhly, following lockout and tagout procedures. Lockout and tagout procedures are used to prevent the accidental re-energization of electrical equipment while it is being worked on. These procedures involve disconnecting the power supply to the equipment and attaching a lock and tag to the disconnect switch to prevent it from being turned back on. Eighthly, using insulated tools. Insulated tools are designed to protect workers from electric shock when working on or near energized electrical equipment. These tools have a non-conductive coating that prevents electricity from flowing through the tool and into the worker's body. Ninthly, wearing appropriate clothing. When working on or near energized electrical equipment, wear appropriate clothing that is made from non-conductive materials. Avoid wearing clothing that is loose or that could get caught in moving parts. 10thly, maintaining a clean work area. Keep the work area around electrical panels and equipment clean and free of clutter. This will help to prevent accidental contact with live parts and reduce the risk of fire or explosion. 11thly, being aware of your surroundings. Be aware of your surroundings and watch out for potential hazards when working on or near energized electrical equipment. Avoid distractions and concentrate on the task at hand. 12thly, never working alone. Never work alone on or near energized electrical equipment. Always have another person present who can provide assistance in case of an emergency. 13thly, following all safety procedures. Follow all safety procedures and guidelines when working on or near energized electrical equipment. If you are unsure about any procedure, ask for help from a qualified electrician. The OSHA Standard 1910.333 A1 states that the energized parts must be treated as energized until proven otherwise. When parts are de-energized, they must follow specific steps. Firstly, determine all possible sources of electrical supply to the equipment. Check drawings and equipment. Secondly, open the disconnecting device for each source. Thirdly, visually verify that all blades of the disconnecting devices are fully open or that the circuit breaker is fully open. Fourthly, apply lockout/tagout devices. Fifthly, use a qualified person to test the circuit elements and verify that the parts are de-energized. The test must also determine if any energized condition exists as a result of inadvertently induced voltage or unrelated voltage feedback. If the circuit is exposed to backfeed, this condition must be corrected by grounding, for example, before any work begins. Lastly, an important final step is grounding all the circuit elements. OSHA mandates specific distances to be maintained around electrical panels and equipment to ensure worker safety. These distances vary based on the voltage level of the equipment. For instance, for voltages up to 600 volts, a minimum clearance of 3 feet is typically required in front of the equipment. This clearance allows workers to safely operate and maintain the equipment without the risk of accidental contact. For higher voltage equipment, the required clearance increases significantly. For example, for equipment operating at 2.4 kV to 4.16 kV, a minimum clearance of 4 feet is necessary. This increased distance provides an additional buffer to protect workers from potential hazards such as arc flash and electrical shock. It's important to note that these are minimum requirements and additional clearance may be necessary based on specific site conditions or the type of work being performed. Furthermore, OSHA also specifies minimum distances for working spaces around electrical equipment. These working spaces must be of sufficient width and depth to allow workers to safely perform their tasks. The width of the working space must be at least 30 inches, and the depth must be at least 3 feet for voltages up to 600 volts. For higher voltages, the depth of the working space increases accordingly. In addition to the minimum clearance and working space requirements, OSHA also mandates that access to electrical equipment be kept clear and unobstructed. This means that there should be no storage of materials or equipment in front of electrical panels or equipment that could impede access in case of an emergency. Clear access is essential for ensuring that workers can quickly and safely respond to electrical hazards or perform necessary maintenance tasks. These regulations are in place to protect workers from electrical hazards and ensure a safe working environment. Organizations must comply with these standards and regulations to protect their workers. Compliance often includes providing training, implementing safety procedures, and using appropriate personal protective equipment.